Hi, welcome everyone. This is Josh Atwell from SolidFire, and I'd like to welcome you to our presentation today where we are going to be talking about progressing slides. Just kidding, SolidFire and PowerShell, and how you can manage SolidFire storage with PowerShell in a VMware environment. And a lot of this is going to talk about utilizing the new SolidFire PowerShell tools and PowerCLI from VMware. First off, my name is Josh Atwell. I am a cloud architect in the technology solutions group here at SolidFire. And not listed on here, but worth mentioning is that a lot of my career has been spent working with PowerShell and PowerCLI. I've contributed to a couple of books on the topic, and it is an absolute passion of mine working with PowerShell in data centers. And so being able to do that as part of my job here at SolidFire and be able to help our customers and partners and folks who are interested in automating their infrastructure with PowerShell, I'm really excited to have the opportunity to talk to you about this. And you know, with any other framework, I'm always open to questions. So if as I go you have a question that you're interested in more clarity on something, you know, I got a team behind me working with me to make sure that I see these questions, and we'll try to get those addressed to you as quickly as possible. So our agenda today is pretty straightforward. I'm going to give you a brief introduction into SolidFire PowerShell tools, which we just GA'd last week. So it is a 1.0 product from SolidFire now, no longer in beta. We're going to talk about how to manage SolidFire with PowerShell. So we'll go over some of the fundamental commandlets that are part of the SolidFire PowerShell tools, primarily for managing accounts, volume access groups, and volumes. I'll allude to some other things, but that's going to be the core focus given our short amount of time today. We're going to talk about how to connect SolidFire volumes to vSphere and how to do that automatically with PowerShell. This is some content that I'll step through, but we'll also talk about how you can get a much more robust script off of our GitHub page. We're going to talk about Power Actions, which is a VMware Fling that I leverage to provide additional functionality. And then I'll give you an introduction to storage policy-based management and how you can manage that with SolidFire with PowerShell. So first and foremost, the SolidFire PowerShell tools. As I mentioned before, this just went generally available. It's a 1.0 product now, and it shipped with about 80 commandlets. And it leverages the SolidFire's full-featured API. Now, SolidFire is an all-flash scale-out storage system, and it was built expressly to make it more extensible and capable to automate against. We recognize that was a fundamental lack in our space, and that there was a really strong need to be able to improve the automation capabilities. So SolidFire as a platform is built with this full-featured API that can be leveraged with a wide range of technologies, languages, and fortunately, SolidFire chose PowerShell to be one of the first languages and integrations that we released for taking advantage of that API. Now, in the 1.0 release, we have well over 200 API calls that can be leveraged. And while each one of those can be leveraged with PowerShell, not all of them are included in the PowerShell tools. In the tools today, we have, as I mentioned, 80 commandlets, and most of those are for managing core components and for gathering a ton of information about the environment. And a big focus was on usability and ensuring that in that core functionality where we anticipate 80% of the work to be done, with the API calls provided, we wanted to make sure that those functioned very cleanly and very consistently with what people who leverage PowerShell would expect. And being that I'm a longtime PowerCLI user, and I firmly believe that PowerCLI is one of the best implementations of PowerShell extension or integration that there is, you'll probably note a lot of similarities between those two. And then the last part I want to make a comment here is that when we release this, we do release this as a module. So it is extensible. Like, it can be shared across multiple systems. We do provide an installer to simplify, your initial implementation, but by no means are you required to use the installer in order to leverage the module. It is a compiled binary. It's a DLL that can be copied to any system, and it can be loaded using import module. And a lot of the stuff that you'll see today, including the module and the installer, are available on our GitHub repository. And that's at github.com/solidfire/PowerShell. All right, so let's go to the lab. And I'm going to share my screen here. All right. So to start with, let's look at what the installer leaves with us. And once installed, the installer also provides this custom shell. It has a little skin wrapped around a PowerShell console, and it gives you a very complimentary initial login, very similar to what you experienced with PowerCLI, providing you some getting started commandlets and some basic information, and then of course the Helix logo and ASCII art. The first thing that I recommend everybody do when they get access to the SolidFire PowerShell tools is to look at getsf command. So getsf command is just like getvi command. It gives you a list of all the SolidFire commandlets that are available. And the very nice thing about this is that when you're doing a git command, typically you would have to specify the module that you wanted to look in and then choose your verb or nouns that you're trying to search against. Using getsf command can get you to that a little bit more quickly. Give you an example. We're going to get sf command, and let's see what we have regarding finding out efficiency information, right? And this is going to be important here in a minute because we're going to talk about using the commandlets that relate to efficiency. So, as you can see, there's plenty of commandlets here, a lot of capabilities. We're able to do more than just manage like volumes and volume access groups and accounts, but we also have the ability to manage snapshots. We have the ability to configure cluster settings, and there are commandlets available for helping with the process of adding additional nodes and adding additional infrastructure into a SolidFire cluster. All right. Now, for this particular demo, we definitely wanted to talk about, as a VMware administrator, if you were going to be using the SolidFire PowerShell tools, what would you expect and how would you get started? So we'll get to that in a minute, but I want to show a little bit about how to manage the SolidFire system itself and some of the common tasks that you'll see from a VMware environment, being able to create the volumes and organize the volumes and make them accessible to a VMware environment. So in our SolidFire system here, I have my system here, and I have a couple of volumes, right? And I have an account, and you'll see that these are built to align with this cluster in the environment. Okay, so those three volumes are named and consistent with what is in the vSphere environment. And I actually did that with a script, which I'll show you here in just a little bit. But the core components that you need in order to deploy SolidFire in a VMware environment, you have to have an account that volumes can be assigned to, and you have to create volumes. Now, in order to simplify connecting the SolidFire volumes to your vSphere environment, in the examples we have today, we're going to leverage a volume access group. And the volume access group allows you to organize the volumes that are in your SolidFire system and be able to tie down initiators that line up with the IQNs for the ESXi hosts. Okay, so that gives you the ability to create that trust relationship and be able to dynamically provision volumes and make them available in the vSphere environment. And here in a little bit, I'll show you how to do that with PowerShell. So let's first go to the SolidFire PowerShell tools. And the first commandlet that most people are going to use is going to be connecting to a SolidFire cluster. So we'll do connect SF cluster. We're going to choose our target, and in this case, I'm going to choose my development node. We'll be prompt for credentials, and then you're presented with information showing that you've successfully connected. Now, with PowerCLI, what happens, and this is kind of like a cooking show where I've already got some of this pre-built. you have a global variable called default VI server when you connect to a virtual center server. All right, looks like I got a little pause on the sharing, so let me stop my sharing. All right, sorry about that. Let's try that again. All right, hopefully everybody can see my screen again. All right, so when you make the connection with Connect VI Server, it stores the connection information into a global variable. We do the same thing with SolidFire, where we store the connection information in a global variable called SF Connection. SF Connection provides the most recent connection that's been made with PowerShell. And we also, just like with PowerCLI, provide SF connections. And if you have multiple connections to multiple hosts, or not hosts, but SolidFire clusters or multiple SolidFire nodes, you're able to do that directly in the PowerShell module by creating each connection and having it stored in the SF connections variable. What that allows you to do is, let's say you want to get volume information. By default, it'll pull from whatever's in SF connection, or you can actually specify a target. So if you have multiple SolidFire clusters, you could specify the target to where you want to collect that information from. This allows you, if you have an environment with multiple SolidFire systems, perhaps you have multiple data centers where SolidFire resides. This is especially going to be useful when we release some upcoming capabilities around replication. Keep hearing that the screen share is freezing, and I apologize for that. So I'll try to make sure I talk very descriptively about what happens, and then as it freezes, I do apologize. These things happen. So what that allows you to do then, going back to target, is that if there's, for instance, you have multiple SolidFire systems and you're setting up replication, you would be able to create those connections in SF connections and then be able to use target to execute those commandlets. That also makes a lot of sense when managing multiple environments and being able to connect up. Let's say you're doing Site Recovery Manager, or you're doing multi-site deployments. Being able to have a single console session open, being able to create those connections, and then simply using -target in order to execute them against each one. We did that very explicitly to make it as easy as possible to implement SolidFire in your environment to manage multiple systems. And also because a lot of our API calls are node specific, to where you can get configuration information for an individual node, and in order to do that, the connection to that node has to be established. And this way you can establish connections to all of the nodes, it be stored in the SF connections, and then leveraged as you use SolidFire, either in the console or when you create scripts to perform tasks. So the first thing that a lot of people will do is they'll want to create accounts, volumes, and volume access groups. So let's start with creating an account. Get SF account. You'll note that all of our commandlets include the verb, hyphen, and then SF. And we do that to help identify the commandlets that are specifically related to the SolidFire PowerShell module. We don't want you to get confused, and we don't want to have overlap with other commandlets that other vendors or Microsoft may have created. So by leveraging the SF, we keep it pretty consistent. So we see we have the 2 accounts now. So let's do new SF account, and we're going to give it a name, and we'll call this Webinar 01. And we have the opportunity to define initiator or a target secret. This has to be between 12 and 16 characters, but if you don't apply anything, then the SolidFire system will define those for you. So when we create that, we get a return back. It tells us now we have an account called Webinar 01. Right? And we can validate that right here in the UI. There we go, Webinar 01. Same can be done with volumes. So we'll say new SF volume. We're going to give it a name. We're going to call it webinar disk. Here we have a few additional parameters that we have to provide. We need to tell it which account we want it to have. And in this case, you can do account ID or you can do account name. Since I have the ID right here, I'll provide that because each volume has to be assigned to an account. And then we're going to go ahead and enable 512-bit emulation. We got to give it a size, and in this case, I'm just going to give it a small size. I'll specify it in gigabytes. We're going to give it a min IOPS of 100. We're going to give it a max IOPS of 500, and then we'll give it burst IOPS of 1,000. Right? And so that goes out and it creates that volume. It provides its SCSI IDs, it provides an IQN, and all the information about that volume is now available. And so that could be connected to a standalone host or to a vSphere host or a vSphere cluster. Right? So just really straightforward stuff on being able to create volumes in account and manage them. You can actually, from there, also modify. So let's say you want to change the QoS profile on the volume. So we'll get the volume. So that's that volume. I hit a V. And we're going to set the min IOPS to 1,000, max IOPS to 2,000, and burst to 3,000. It'll prompt if you want to make a change, you say yes, and then now that has changed. And it looks like I got disconnected and reestablished. Excellent. Gotta love consistent live demo, right? At least the environment's working well, even if the sharing isn't. So if you missed seeing that, I essentially did a get volume. I typed it to set volume. I changed the QoS, and now we can look at the QoS profile for webinar disk. And all we have to do is expand the property QoS, and it will show us that we did 1,000, 2,000, 3,000, and you can refresh that in the UI and be able to see that that was the case. Now this is all pretty straightforward. This isn't anything super fancy outside of the fact that you can do it with PowerShell. But where the real value in the capability comes in is that because we have this capability and because PowerCLI has the ability to leverage its commandlets for establishing connections, we have the opportunity now to completely script the task associated with adding storage to a vSphere environment. And if you were to visit our GitHub repo, which is github.com/solidfire/PowerShell, you'll see that we do have a VMware directory, and in there we provide a lot of different examples of how you can accomplish some of this, but we also provide a function that will do it end to end. And just like with baking, I've already got the functions downloaded. I've got them loaded into this system, right? So you'll see we have new tenant or cluster. That function is loaded. And what I want to show you is that I can actually now take this cluster, which has no shared data stores, and from there we can deploy out storage using a simple function. So I'll do new tenant or cluster. We're going to give it a cluster name, which is cluster 02. We're going to tell it 3 volumes. I'll give it a size. In this case, I'll do 10 gig. We'll do a minimum of 1,000. Let's do 1,500 IOPS. We'll do a max of 3,000 IOPS and a burst of 5,000 IOPS. And I do apologize. It seems this connection keeps dropping, and I'm not sure why. I'll blame Time Warner Cable. All right, and I'm going to go ahead and set verbose on this so that you can see all the steps in action. So when we go to execute, it will create a new account for the cluster. It will then go through and it will create the volumes. It will assign the volumes to a volume access group. It collects the IQNs of each of the ESXi hosts in the cluster, and then it applies those to the volume access group so that the volume access group knows that the IQNs are on hosts that we trust, and it exposes those to the ESXi host. Then rescanning the HVA, we see those as targets. We're able to then add them, and in this function, we actually add those data stores as with the name the same as the volume itself. And what you now see is that we have indeed added 3 new data stores into this environment in the matter of about a minute. It doesn't take very long. And we're able to do that end to end, right? Now in this situation, obviously I'm using volume access group and I say a specific cluster, but by adding an additional parameter, I could set this up to be a, let's say you're adding a new tenant or a new business unit or a new application stack that's going into this, this cluster, and you want that to be added and you want that to be made available. You can do that by simply specifying that name instead, and it can still pull dynamically all the information from the ESXi host and pull that in order to make that connection. So once we have everything in there, and I heard it froze again, and so hopefully everything is showing up okay. Once we have it in there, now we have storage that's been allocated, and we can work under the premise that we have been operating this environment for a little while, and situations change, right? We either need to modify the QoS, maybe we need to query information, we need to change some settings or get some visibility into what's going on. Well, now you're able to go in and using PowerShell and PowerCLI, you can actually, and I think I just showed you this a minute ago with changing the QoS settings on a volume. You can do that directly through the console, or I am actually preferring doing something lately, leveraging what's called Power Actions. Now, Power Actions are a VMware fling that allows you to install, in short, a PowerCLI console directly into the vSphere web client. So whether you're running a Mac or whether you're running Linux, whether you're running Windows, you have access to PowerCLI directly through the vSphere web client. Now, it does still require that you provide a remote PowerShell host, and that host is where all the PowerShell gets executed, right? So you're not getting completely away from Windows in this respect. You're still required to maintain a system that can actually execute PowerCLI commands, but this does provide that functionality and capability directly in the vSphere web client. It allows you to also build and share scripts. So you can actually write a script that will perform an action or execute and return a report and store that directly in the vSphere web client for the purpose of sharing. So there is a shared directory that you can place all of these items to make them available to other administrators and other people in your environment. Now, by leveraging this, plus by defining some credentials for leveraging it, you now have the opportunity as a storage administrator to be able to provide functionality to your VMware vSphere environment administrators, give them capabilities to perform tasks without actually having to reach out to the storage team. And because it can be scripted and shared and locked down from making modifications, you can actually set up rules and based on how much they're able to change at any given time, so that it gives you a little more flexibility to self-enable vSphere administrators to do the things that they need. Now, one of the things that I will point out is that they are context aware, so that you can, I have some Power Actions that I'll show you today that can be leveraged against an ESXi host or can be leveraged against like a data store. And when you create the Power Actions, you have the opportunity to specify what the target, context target would be. What type of object are we talking about here? And let's go back over to the lab, and I'll show you what this looks like. So first and foremost, let's go and look at what Power Actions look like in the environment. Now, the console is pretty straightforward. You just saw an image in the slide, so I'll skip on that. But let's go into looking what the PowerCLI scripts look like. Now, these are all scripts that I have written and I have placed in my scripts, which is kind of local to me, and each one performs a specific task. And you can see that the target type is defined. Now, most of these are set on host system because I've been working lately primarily on helping people managing VMware on how to configure the system and get information about the SXI host and how it relates to SolidFire. We'll talk about that in a minute. But we're also creating some that deal with data stores, and we'll show off those here in a second. There's also, as I mentioned, the opportunity to do shared scripts. Okay, now I don't have any of my shared scripts right now because frankly I don't share this virtual center server with anyone, and so there's not a whole lot of valid reason for me to put it in there. But it's really straightforward to accomplish. And when you look, you'll see, and let's go ahead and do an edit here so we can see this in a larger screen context here. You'll see that the format of the scripts there are actually just like functions, right? Where you define your parameters and whether or not they're true, whether or not they're required, whether or not they're mandatory. And with all the Power Actions that I create, I also work to prompt the user for credentials. Now, you can store the credentials in there if you would like. There's a variety of ways of doing that, but for the sake of how I want to share with the world, I would just assume that each organization ensure that only people who have appropriate access be able to do that. Right? So if we wanted to set the QoS on the data store, what we'll do is we'll go over to storage, and let's just pick cluster 02-3. Right? We would simply right-click on that, go to PowerCLI, and we'll select Execute Script. We're going to set the QoS on the data store, and we'll say OK. We provide the cluster. We'll provide what we want our minimum, maximum burst IOPS to be, and I'll just do 2,500, 5,000, and 7,500. It will prompt for credentials, so I'm going to do this for an admin account. It'll ask me to provide my password, and then it'll go out and execute the script. And I have told it to return and tell me what has been updated. Let's go see if that happened. All right. If we hit refresh here, we'll see our additional ones have added 2,500, 5,000, 7,500. Now, when you think about the use case for that, one of the things that I talk about frequently with customers and folks who are looking at SolidFire and automating SolidFire is that what happens in those scenarios where you have an application that has been running, and let's say a database application, and it's been running and it's not finished, and it should be finished. And it's creating a little bit of havoc because it is, for instance, payroll system. And you're concerned about that system actually finishing so people get paid within a certain amount of time. Well, as it stands today, most organizations are forced to either stop it, try to sort out what happened, and then hope that they can rerun it in time, or just allow it to finish and then root cause it later and see what's going on. In those situations with SolidFire, however, vSphere administrator, if allowed to, could simply right-click on the data store serving that up and increase the IOPS that are available to that data store for the period of time that is needed. And then they can go in and change that back. And they can do that without actually having to interact with the storage team at all, which provides a considerable amount of capability that hasn't been available. So that scenario goes from somebody getting paged and having to get in and trying to sort out what's going on, and it goes back to them being able to solve the problem themselves rather than having to do that page out. So that's one of the use cases there. Another use case is being able to write scripts so that at specific times of the day, you would modify the QoS settings for volumes that are serving specific types of applications. So at SolidFire, we're very much inclined to have multiple types of workloads present on the same SolidFire system. So your VDI workloads, your database workloads, and general virtualization workloads, no problem putting them all together. We are a multi-tenant focused system, and our quality of service enables us to enable that. So what we do then is we allow you to be able to set, for instance, a scheduled task so that the QoS on a volume could be changed. Let's say the ones for the VDI environment could be changed at, let's say, 7:30 a.m. when people start trickling in and boots start happening, and then change back to normal at 9 a.m. when most everybody has already come in. Well, now you've enabled the capability for the boots of the VDI instances to happen more quickly without negatively impacting anyone, and all that is required is that you have available performance on the cluster. So another thing that I see people are interested in understanding, and I've created a power action for, is if you go in and you can do an ESXi host, you can execute a script and you say, well, which volume access group is this associated with? So we're going to get the SF volume access group, provide the cluster, and yes, I have one of the loudest keyboards known to man. Apologize for that. I wanted you to know that I was really typing. And what it'll do is it'll go in, it'll pull in the ESXi host, it'll tell you the volume access group, and it'll also tell you the IQN. And if you felt so inclined, you could always go in and you could look at that volume access group, and you could look at the IQN where it was assigned. Okay, so this also gives administrators the ability to very quickly work towards troubleshooting, or if they do need to make a request to the storage team for something to be modified or changed, and finding information like that is useful, they can pull that information very quickly without necessarily having the full SolidFire PowerShell Tools module loaded on their system, or even leverage PowerShell at all if they choose not to. All right. So one of the other things that I think is really important to make note of when you look at SolidFire and VMware and working together with PowerShell is the utilization of two components of each that I think are widely underutilized. And I've talked about this at a few VMUGs, and it's been pretty consistent. So in Virtual Center Server, there's the concept of tags and tagging. And so if we go into the administration side of things, we can see that tags. And for this environment, I've actually already created a few tags. I'll go ahead and delete those because I want to demonstrate how these are made. But the tags that you saw there were tags that were aligned with a data store. And what happens is that data store object is tagged with that tag, and the tag gives you an opportunity to provide additional collective understanding about the things that are tagged. So if something was tagged HIPAA, you would identify that and put onto a data store or onto a cluster. You could say that this cluster, this data store, it meets our HIPAA requirements, and as such, when you use things, now we can audit against that tag. Well, with SolidFire, we actually have something that we call attributes. And so when you look at our volumes, you can actually look at the volume details, and you can apply what we call attributes. Now, I did that for cluster 01-1, and so I'll show you how to do it with PowerShell. So we'll do get F volume, and let's do cluster 02-3. All right, so there's our information. You'll note that attributes is empty. And actually, I don't know Yep, I got to go to the pre-baked side. So let me do that again over here. All right, so there's that. And what I'm going to do is I'm going to set SF volume attribute. And now this is a function that's available in our GitHub repo that will allow you to set the attributes on a volume with a little bit more flexibility than what is available natively in the set SF volume commandlet. So we're going to apply the attribute name, and we'll do workload. We're going to give it a value, and we're going to call this one, I think I did MongoDB on the other one, so let's call this one something different. We're going to call this one MySQLDB, or Microsoft SQL DB. All right, so now we've changed that. And so what we can do is we can expand the property, and you can see that that workload is made available. What we're able to do from here is we can actually leverage PowerShell to create awareness between the SolidFire system and Virtual Center server to where we can read these attributes in and create and assign tags on the vSphere side that would associate with them. Right? And on GitHub, if you're so inclined, you can go in, and I have provided a full module full of different functions that will allow you to perform these tasks. So for instance, the new tag from SolidFire workload. All right, let's open that one up real quick so you can see what is involved there to give you an idea of how this would work. What we do is we provide the volume. We tell it what type of category we would want the tag to be associated with and what attribute we would want. Now, I've already predefined what, from a SolidFire perspective, I would want my category to, it's freezing, is absolutely driving me crazy. I really apologize, everyone. I'll leave this part on screen for a minute so that you can see. So in my parameters, I've already predefined, that I want my category to be something SolidFire related, and that the default attribute that I use is workload. Okay. You don't have to do that. You can actually run this function and choose a different category or an attribute. That's the beautiful part about advanced functions in PowerShell. But what we do here is that we define the workload to be the attribute that's associated with the volume, right? And that's the volume that we passed in. And when we do that, we check to see if it exists. And if it doesn't exist, then we go and we create it. And we create it with the category that we provided. So we create a new tag category, right, based on that. And then we create a new tag that's based on that workload. Okay? And in the description, we say that, this was based on this. All right, so let's run that real quick, and let's run that against the volume that we just changed. So let's clear so we can get up top. So we'll say new tag from SolidFire workload. We're going to get our volume, and let's do get SF volume cluster 02-3. And we're going to skip category, and we're going to skip attribute because we want to use the default. And if everything goes as it should, it will go in, it'll read that information, and it'll create a typoed Microsoft SQL DB. I really wish I understood why the network connection keeps locking. Very, very sorry about that. All right. It will create a typoed Microsoft SQL DB. All right, and so if we go into vSphere, and we can refresh here, we'll see that now that tag is available. All right. Now, from here, what we're able to do is now we can modify our, take these tags and modify our SolidFire volumes dynamically make changes to them, and the associated tags would be created and the volumes assigned. So if I did GetSF volume cluster 02-3 and set SF volume attribute, and we're going to do the attribute name being workload again, and we're going to change the attribute value to be correct, right? It'll go in and fix that, and then we can run this guy again, and it'll be correct. So we go back here and refresh. Go to our tags. And then we can just get rid of this guy because now it's no longer there and it's no longer associated. All right. Now from here, and then actually now that I think about it, let's make sure we go look at our storage, make sure that that got tagged. Oh, that's right. I created the tag. I didn't assign the tag. Sorry. That is in the next function. So what that allows us to do now is we can actually create entire policies based on these attribute and tag comparisons. And I'll talk real quick about what this looks like, the storage policy-based management. So storage policy-based management is the ability to define policies that can be aligned with data stores and disks in a vSphere environment. Now, SPBM has been around for a little while, and it really hasn't been leveraged that much. Most of the time it's leveraged when you're dealing with multiple storage tiers because there are multiple arrays, and then you would assign either using the VASA provider or by using tags, create policies so that people know that they're deploying to the right spot. With SolidFire, what I've done is by leveraging attributes, by leveraging the QoS policy that's associated with each volume, we can create very granular and specific policies that are based on that attribute and based on QoS. So as you see in this image, I've got policies that are representative of the characteristics of the volume that are supporting that environment. And so using tags gives us the widest range of capabilities. We can be extremely custom in what we do. We can apply tags to multiple data stores at one time. And that means we can assign these policies to any data store based on those tags. And so you can also use that compare against multiple platforms. So if you have multiple arrays in your environment that are servicing different tiers of storage, but they have common features or capabilities, you can accomplish exposing that to your end users. Unfortunately, it isn't traditionally a very dynamic process. This is one of the main reasons why I built automation using the SolidFire PowerShell tools and PowerCLI, because maintaining it can be kind of cumbersome, and I think it's one of the reasons most people haven't implemented it. So what we'll do now is I'm going to go over here, and I have this new SPBM policy from DataStore where what you do is you go through, you identify the workload just like we had done before, you create a tag if it doesn't exist, right? You pull the data store, you tag the data store, and then you create a policy based on the attributes of that volume that supports that data store. All right, so what we're going to do is we're going to go, let's pull up vSphere, let's do this. We're going to do new, what was it, SPBM policy. SPBM policy from data store, and then actually I'll do get data store cluster 2-3, and it will go. Well, that wasn't expected. Okay, there it is. I have a typo. Typos happen. There it is. Okay. Of all the times it could have frozen, it didn't here. And it did froze. Okay. Let's see if I can get that restarted. All right. And then what it's going to do is it's going to collect. Still has a problem with that data store. That's very interesting. Honestly, not sure what's happened there. I really apologize. This worked earlier. Let's try a different data store and see if maybe that's it. I don't think it is, but this is the beauty of live demo. Nope, still doesn't seem to like it. Interesting. All right, well, unfortunately, I can't show you how that works. I'm not sure what has happened here, but what would traditionally happen, and I know the code works because I've used it numerous times, so I'll have to beg your pardon then. What will happen then is that it will go in and it will create, let's go to policies and profiles, it will create storage policies that are representative of the different type of disks that are associated. So you can actually get data store on all the data stores and pipe it into that function, and it will run through and make that modification, create all your tags, create all the policies, and assign those data stores to those policies so that when your users go to deploy a virtual machine, they're able to select, and I can show you that in progress. They can actually create a new virtual machine, and we're just going to put some bogus information in here just to move through to the end. Create a resource, and right here they can actually choose the policies that they want. Right. So in this, we'll choose that policy. There is a data store that's available. There's not one that's available right now because that broke. And then when you go into your dynamic, creating your hardware, you can add a new hard disk. And then you have the opportunity to expand that to choose a specific policy for that one.